Okay, so now we're going to talk about a magnitude of a vector. And basically, the magnitude of the vector is just the distance that vector has to travel, or the length. It looks very much like Pythagorean theorem when you're trying to find the hypotenuse. Because when we try to find the hypotenuse, when we take the square root of both sides, it's basically the hypotenuse equals the square root of a squared plus b squared. A and B referring to the legs of your right triangle, and also A and B referring to the parts of your components. So let's say that vector V has a component that is at -4, +4. And I need to find the magnitude of vector V. So you'll see that notation, it looks like absolute value. That means magnitude. And it's going to be the square root of A squared plus B squared. So -4 gets squared, +4 gets squared. When you're squaring a negative, that becomes a positive. So -4 squared is 16. +4 squared is 16. Add those together. 16 plus 16 is 32. And then you're going to be asked to simplify the radical. So when I'm simplifying this radical, I'm going to think of the factors of 32 so that one of those factors is a perfect square. And 16 is the largest perfect square that divides into 32. 16 times 2 is 32. And when I think of this being underneath the radical, I can take the square root of 16. It comes out as a 4. The 2 is not a perfect square. It has to stay underneath the radical. So 4 square root of 2 is going to be the magnitude of this vector, or the length of this. You can go to your calculator and figure out like what that is as a decimal. So 4 square root of 2 is about 5.6. And so that would be the length of that vector. But I want you to keep your answers exact. And that's how you find the magnitude.